Hello everyone. Welcome to Chapter 5, which is our unit on logarithms and log functions and exponentials. For day 1, this video will take you through how to actually use your calculator to graph these functions. Because exponential functions, there's normally a really big intro I do for this, but I'll have to do it on this day 2. But logs are kind of cool. They grow exponentially, which means they grow very quickly. And you know, we're just talking about functions that do this. So what are the graphs going to look like? Well, we'll see in a moment here. So to use your calculator to graph these, because we get some very odd numbers like decimals or very large numbers as well, we're going to use our calculators to actually go through and do this. So if you take a look at your calculator, what we're going to do is we're going to graph the functions that are exponentials. An exponential means we have an exponent taking place in the problem. So we have 2 raised to the x minus 4. So what we're going to do is go into y equals, and we're going to graph 2 raised to the x minus 4. Okay. Now, we're going to take our table right here, and we're going to go ahead and graph this using the table. So let's hit second table. And what we're going to look for are some values that actually make this graphable. So for example, 412 is a good point, but it goes off of the graph. So we want to try to use values that do work. So we have 3, 4 here, which is a good point. 2, 0, which is a good point. 1, negative 2, 0, negative 3, and negative 1, negative 3.5. Okay? Now, let's take and plot each one of these points. So 3, 4 is going to be right up here. 2, 0 is right here. 1, negative 2 is right here. And then we have 0, negative 3, and negative 1, negative 3.5. If you were to continue making points along my graph, you would actually see a curve that would end up looking just like this. What you could see is the graph starts off very slowly doing nothing, and then it gradually starts to pick up. Then all of a sudden it just takes off, skyrockets, and we get this curve that is growing very quickly. So our graph, if I was to make this, would look like this, okay, going straight up ultimately. Okay, that's what exponential growth looks like. Let's look at one where there's logs taking place. Okay, now log, I'll get into it later on in class what a log is, but logs are basically functions that are used to determine answers for exponential problems. So it doesn't mean much now, but it will mean something later. So how do we go about graphing this when we have a log? First of all, there's a part to a log here. There's 2 parts. We got the part that's directly in line here, which is x, and then we got this 2 down here, which is a base. The correct way of saying this is log base 2 of x. So again, this is log base 2 of x is the way we'd actually go about saying this if we were to verbalize it. So when I say log base 2 of x, that's what we're going to be putting in our calculator. Now, common mistake when people go to put this in their calculator is they try to go, the log button is right here. You got log and natural log. That's log and ln right there. Log and natural log. They try to take log and put it in as log 2 and then x. Problem is that when you look at this, it says log 2x. It doesn't say log base 2 of x. So there is a way on the calculators to go about doing this. If you hit alpha window on the calculator, your options will pop up here that show one of them being log base. If we do log base and hit enter on it, you'll see we actually get a log and we get a lower square and a bigger square on the top. So we're going to just fill in those parts. So we're going to go 2x, enter, and now we're going to go ahead and actually look at the table for some values. Now, you'll notice we get some error messages, and if I keep scrolling up, there's a whole bunch of errors. There's a whole bunch of undefined values for this problem, and we'll talk about those at a later time. But let's look at the values that do work. The first one we get is at 1, 0. Next one we get is at 2, 1. Next one is at 3, 1.585. And the next one is at 4, 2. And then 5 and 3 are 2.3219. Okay? Graph each one of these points. So 1, 0 is right here. 2, 1 is right here. 3 and 1 and change because it's 1.585. 4, 2. 5 is just a little bit higher. And we get this curve. Now, look at what the curve does compared to, on my graph here. This is what our curve looks like on the graph. Okay? Notice right here our graph suddenly stops. It doesn't go any further to the left. That's why we had those unknown values there. When we looked at the table to the left of 0, it was unknown. There were error messages. We'll talk about those later when we start talking about domain restrictions and everything. But in terms of the graph, if I was to graph this, this is what our graph would look like. Okay. It's going up slightly as we go to the right, and it's just coming down here, getting closer to the y-axis, but never touching the y-axis. So technically speaking, if I was to get infinitely close to this, it would never actually be touching the line. Now, some of you were doing this and you're thinking, oh, my calculator won't do this really cool function on here. It won't do this log base 2 of x because I have an older calculator or I don't have the operating system. Well, there's a way around this. You could do what's called change of base on your calculator. To do change of base, or not even on the calculator, just on paper, but to do change of base, we can take this and rewrite it as a fraction. And it's a fraction of 2 parts. Logs normally have a base of 10. So what we're going to do is we're going to rewrite this as a fraction with log of x over log of 2. So this is called change of base, log of x over log of 2. So we're going to go log of x and divide it by log of 2. What that does is it makes a base here of log, which is 10. Well, we'll talk about them more later. And then same thing here, this is log base 10. Logs normally have a base 10. That's why if you look at your calculator here, right above log, it actually says raised to the 10, or 10 raised to the x, because the base of logs is 10, and then natural logs is e, which we'll talk about later. So to put this in the calculator, if I was to go, again, go log of x divided by log of 2, that's just what we did here, the change of base. You'll see when we look at the graph is the same as the one we just did. In addition, if we look at the table of values is also the same. At 1 we have 0, 2 we have 1, 3 we have 1.585, and so on and so forth. Okay? I hope that helps in terms of graphing of these. Your first day's assignment is real quick and easy. You're just taking your calculator, graphing these, filling in a table, and just looking at the way the picture looks. Hope this helps. We'll talk to you soon. Okay? Bye.